So those are some of the other some of the general statements I wanted to make. And later on today, we're going to hear some papers on systems biology. Engineering approaches tend to be very direct. A great example is you want to go to the moon. Well, you can go outside on most nights and you can see the moon. You actually can see your goal. But very often in basic scientific research, if you wanted to discover new things, then what you don't want to know to start with is what the goal is, because that's something you already know. And what you want to do is discover something nobody ever knew about. So how do we, but in applied research, we're very keen on getting from Earth to the moon. We're very keen on making a particle of a particular dimension that has certain binding characteristics that will direct it to a cancer. And if you make some observations en route that are not part of the pathway, are not part of the benchmarks that you have to pass, you are cautioned not to take and look at those things. Well, that's not what companies should do, and not what companies should go to the goal. But academic scientists are the ones who are, in effect, paid by the taxpayers, by the government, to do basic science and to investigate these things. So the important part is that if we continue to apply what we know, we're never going to learn anything new. We're doomed to continue in the same process. But if we can learn that we should be able to follow directions that are piqued by our curiosity, or that emerges along the path of application or to reach a very well-defined goal, we should have there should be something in the system that allows that to flourish.